In today's lesson, we'll continue our video series on inequalities, and in this lesson, we'll be looking at quadratic inequalities. So, quadratic inequalities are basically inequalities that have the form of a quadratic equation. So, we know that the standard form for a quadratic equation is ax squared plus bx plus c is equal to 0. This is the standard form of a quadratic equation. But for a quadratic inequality, the only thing that's going to change will be the sign here. It's either going to have greater than or equal to, or maybe a less than or equal to. So that's a quadratic inequality. And you find that the way we solve this is similar to the way we solve quadratic equations. So let's try to look at an example and try to see what we mean. So let's say if we had x squared plus x minus 6 is less than 0, and we're being asked to solve this quadratic inequality. So the way we would solve this, you can use any of the methods that I taught on solving quadratic equations. Those methods also apply here. Methods like factorization, completing of squares, and the quadratic formula. So in this example, I'm going to use the quadratic formula. So we're going to say x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. And what we are finding when we do this are what we are calling the critical points for this given inequality. And critical points are just points that will make this inequality be 0. So we need to find those points. And we need to find our a. Our a is 1, our b is 1, our c is negative 6. So we just need to replace in our formula. We have negative 1 plus or minus the square root of 1 squared minus 4. Our a is 1, c is negative 6. And this is being divided by 2. So what we're going to get is going to be negative 1 plus or minus the square root of 1. This and this will become positive. 4 times 6 is 24. So plus 24. And when we add these two, we'll get 25 over 2. And we know that this is going to give us negative 1 plus or minus 5, since the square root of 25 is 5, divided by 2 as our x. And what we can do is separate these, where we have x1 to be equal to negative 1 plus 5 over 2, and our x2 to be equal to negative 1 minus 5 over 2. This is going to give us 2. So we're saying x is equal to 2, or x is equal to negative 3. This is what we're going to get. And these are what we're calling critical points. Okay, so when we have this, we can also say, write it like this: 0, x plus 3 is equal to 0. So we need to replace these now in our quadratic inequality. So what we're going to get will be x minus 2 x plus 3 is less than 0. So that quadratic inequality that we had here, you can simplify it to this. Okay, let me just remove this part. This is what we're getting. So for you to find your solution now, you can write your solution in form of interval notation. So what you need to do is draw up a number line, and on the number line, what you are going to do is you're going to put those critical points that you found. So we said that negative 3 is a critical point and 2 is also a critical point. And you are supposed to put a circle on these critical points. So the type of circle that you will put will depend on the sign that you have. If the sign is less than or greater than, the circle that you put will be an open circle. If the sign was a greater than or equal to, a less than or equal to, or a greater than or equal to, the type of circle that you're going to put will be a closed circle. And from our case, we found that we have a less than. So the type of circle that we're supposed to put on the critical points on the number line are open circles like this. Okay, so once you put those, we are basically going to divide the number line into three portions. So you have this side, you have this side, you have the middle part, and the left side. So in each of the sides, you are going to pick a number. So here I'll pick 3, and at this part of the number line I'll pick 0. This side I'll pick -4, and we'll try to see if the solution lies in any of these regions. If the solution is in this region, maybe this region, this region. That's what we're going to do. Okay, so you need to test if the statement that you are going to get, if let's say you replace 4 here and here, if the statement that you are going to get will be true. So let's see what I mean by this. So we start with the leftmost part. We are saying that x minus 2 x plus 3 is less than 0. So let's replace 4 in here and see if the statement that we're going to have afterwards will be true. So when we replace -4 where there is x, it's 2 here, and then here you replace -4 plus 3, this is 0. What are we getting? We are getting -6. Here we're getting -6. Here we're getting -1 is less than 0, and this will give you 6. Is this statement true or false? Is 6 less than 0? No, 6 is greater than 0. So this statement is false. So here you have false, meaning your solution cannot be in this region going this direction. No, see, it's false. Let's try the middle part and see what we get. For the middle part, we are going to put 0 where there is x. So we're saying 0 minus 2 and 0 plus 3, 0. So here you get -2, get 3. This will give you -6. Is this statement true or false? Find that -6 is less than 0. Yeah, it's true. -6 is truly less than 0. So this statement is true, meaning that your solution can be found in this region here. What about the rightmost region here? So for that one, we are going to test it as well, and we are going to replace 3 where there is x. So what we're going to get is 3, plus 2, then you have 3 plus plus it's what? It's 3. Okay, 3 plus 3 is less than 0. So here you get 1, and 3 plus 3 is 6, is less than 0. 6 is less than 0. Is this statement true? No, 6 is not less than 0. So this statement is false, meaning that the solution cannot be found uh, in this region going to this direction. So from this we'll find that the solution is only being found here. Okay, the solution is only being found here. So we need to write our answer now in interval notation. So to do that, we are going to say the solution set is, so you just get this region here. So the type of bracket that you're going to have, we discussed when we were looking at interval notation, we said that when you have a closed circle, you use this type of bracket. When you have an open circle, you use this one. Okay, so we're going to use this one, where we're going to say put -3, comma 2, and even the other side we have an open circle, so we put that one. So that's your solution in interval notation. Okay, so that's how you solve this question. If there are any questions, you know how to contact me. That's my number. Text me on WhatsApp. Bye bye.